Hello everyone! Hi, GodotCon. Hey! Yeah, so I hope you guys are still awake after all these events and potentially the pre-meeting, because I sure am not that much, but let's go. So welcome to my talk. Let, let's say you're making a game, I know, wild assumption, and you're probably gonna use an engine, which I can also guess which one you're gonna use, but let's go through the process again. So you got several choices open to you. First one will be general purpose engines, which like Godot, which are flexible, but at times the workflow may be a bit inefficient for the game you want to make. You could also get a specialized engine, like RPG Maker, all of that, which is very efficient to use and very fast to start, but we can quickly get limited by what the options are available to us. Or you could go full hog and make a custom engine, really strong, optimal, but that's very long to make, very hard to make. You want to make a game this century, But is there a better option? Well, not sure about better, but might be more suited to what you want to do. You could take a general purpose engine and to specialize it for your workflow. And so today I'm going to tell you about the why, what advantages can you get by doing that instead of just using another type of engine, how you can integrate it in production, and how to continue making games while you're doing that. And I'm going to also talk about the users, which are actually the key part of this. Since you want to be efficient, you want to be your developers to go well. And for that, I'm going to use as an example the framework I've been building over the last 3 years, which is Castagne, which is a creation framework for fighting games built in Godot. So, a bit of a tangent. Who am I? So I'm Panayotis Tsiapkolis. So I'm a 3D programmer or rendering engineer, professionally in the AAA game industry. And I'm currently finishing up a PhD on styles rendering for games. Maybe you know me from last year when I did something on non-photorealistic rendering. And my PhD is on line drawing, which is, it's cool, I think. I enjoy it, mostly. I'm also mostly self-taught. Now it's been 7 years of Godot, but programming for 20 with the old stuff. And what I like actually in programming is software architecture and rendering. I also like math. That's so you can guess what type of person I am. But Castagne, maybe you haven't heard of it, which would be weird, like it should be widely known worldwide. But it's basically a game. Framework for making fighting games. That's pretty flexible. And the objective is to allow to make that very efficiently. That's why it has its own custom editor, which has its own custom scripting language. It's made to handle rollback netcode, which fighting game heads know what I'm talking about. But it has a lot of constraints. So that means it also has a custom physics engine. And I've made sure to make it extensible and to have some collaboration feature. This is a screenshot of the editor, actually. Like on the left, you can see the game is running all the time, so you can iterate very quickly. On the right, you have the code for each attack that you want. It will make code analysis in real time in order to display additional data. For instance, here the hitboxes on the robot. And to allow you to navigate which attacks you have more easily. You have the documentation on the right. You have several tools you can use to help you. But I'm going to talk not about the specifics of how I did it, but more about the logic behind it. And that's why. Why will you want to do that? So what you want to search for is for your unique needs, if you have some. For instance, that might be performance. You might need some unique optimizations. It can be a bit complex. Well, you need some tools to make that complexity work. That can be balancing. If you do a competitive game, you can't test every combination, especially with what the players can find. It can be a very ambitious project, in which case you also need tools to support that. So that's what you have to think about. What unique constraint do you have that might need some very specialized tools? And for Castagne, that's rollback netcode, again, which says that you need to have your game be cross-platform deterministic and to have and to work at 500 physics frames per second. So that's an issue. But the key you actually want to think about is the iteration time. Because the paradigm changed. We are not anymore at we have to make the game fit into the cartridge. We have to fill up the disk, or I guess the disk drive now with the 200 gigabytes game we had today. But Usually it's the Blu-ray disc. But you also want momentum, because if you can iterate quickly, you can make more game, but you can also make it faster, prototype it faster and try it out. You can also get more quality, because it's iterative. You try something, you see what works, what doesn't work, you refine it. So you get more polish. But something that you might not always be aware of is that fast iteration is transformative. That means that you don't only get more game, but you also try new ideas, so you find new paths. I'm gonna use a simple example because, that's pretty abstract. I'm gonna use one from my favorite dungeon in Ocarina of Time. I'm not a contrarian. If you play the Water Temple in the original version, you often have to sink to the bottom of a pool and to get back up using some boots. And the way you do that is you have to open the pause menu, it takes a second or two, you have to navigate to it, equip the boots, walk, then open the pause menu again, take out the boots, and then you're out, That takes some time. That means you usually tend to think about what you're gonna do. But if you're like me, you don't like thinking. No, that's a joke. But in the remake, you can just put the iron boots on by pressing the button, just walk, just get out. And that way, what does that change? That means you are actually trying out more stuff more easily. Because if you have to wait for 2 hours for your iteration, your gameplay change to be registered, that means you probably will have to think a lot about what game do I want to make, will it do, instead of just, hey, what happens if I put the momentum at 500? And you see, oh, it's funny actually. Maybe if I could make it bounce off the wall, that could be a fun move. And then you have a new path that opened to you because you were able to try out new stuff. You can also do some very domain-specific tools because you know your domain. You're not Godot. You're not trying to make both FPS and 4X and all of that. You're making a specific game. So you can know what you need and what you don't need. So that means you can save development time too. And you can make that for any core systems. Like in bullet hells, you can use a bullet path creation or platformers, see what part of the level you can actually access. Domain-specific languages, or DSLs, can be excellent for programming complex gameplay behavior with that. For instance, in Castagne, we have Castagne script, which allows you to make fighting game attacks in 5 lines or something and make them as complex as you want. And it's robust to a lot of situations like air hit, corners, and using the editor to help you out with that. Another one, for instance, is gameplay tests, because as developers, we love tests in theory. We don't like making them. But in games, that's even harder. If you ask any QA guy, he's gonna tell you, we don't make tests. But you can, because you know your game a lot better, you can make a lot better tests. You can ask questions like, can the character jump 3-block diagonal gaps? For instance, get some beef. What resources and units does this RTS build order get me? What's the time to kill in my FPS at various ranges and accuracies of my gun? For Castagne, fighting games, there's the combos that take 5 minutes to make, and I can't actually do them very well. If you look at me in tournament, I'm horrible. And that's why we have combo unit tests, which aren't merged yet, but which allow you to replay an input. It will display the damage and the frame advantage of the whole combo, which is very useful because now you can just, once again, change development, because you can just change a few values and you can see, is my combo still working? Do I have to, you don't have to try it out every time, and you can see very quickly what the changes actually made. But now that you're convinced, or anyway, the door is closed, you can't leave. But the thing is that you want to make that and make a game, because it's a complex and massive project, You can't just make these tools once. You have to be able to reuse them through good code architecture and project management. And while that's a bit too long for this kind of talk, here we're going to talk about how to find that reuse potential, how to not waste time on less impactful code, and how to produce games while you're still building your tech. So for the first time, the thing is that you want to find the technical core. So the technical core is not the core of your game. It's the core of the code of your game. What does it rely on? So, and the way to do that is to find, for instance, how to find what you can reuse. You have to project yourself in the future. What do you want to make? And especially something you don't always think about, but how do I want to work? Because you're gonna do that for a lot of days. One tip I can give is, you can imagine, how can I make this game in my tools? And that can be an existing game, how I can make Street Fighter or something. How can I make a game and with an existing project or an existing game or project you want to make, but you have to not make your scope explode. But you want to keep the door open. That means you're like, yeah, I can do that later, but so I don't close out this with the technical choice, but I don't do it now. For instance, fighting games. You have a lot of systems in common. The attack logic, the startup, the recovery, the attacks, you have the inputs, the double pretzel people talk about. And you got a lot of cancels, like attacking once, link the other attack, all that. That's part of fighting games. But what it actually relies on is a state machine. Each attack is a state. Each walking state is a state. And every entity has a lot of dreams. Like, I think it's a few hundreds, actually. And the tools revolves on how to author these states and how to adjust them. So what other genres actually would benefit for this kind of technical core? Well, beat them all and character action. That one's easy. That's just a single-player fighting game, or with core. So, you can see you need multiple AIs, so multiple entities. That's something you have to keep out, not just 1v1. You also got platformers. Like if you looked at some of the platformers which have like, long jump, salto, triple jump, you got a lot of variations. And usually the best way to do that is through a state machine. And that's exactly the technical core. That's a way to remind it. But you also want to not reprogram everything. Otherwise, you're just making a custom engine and you're losing a lot of time. What you keep in mind is that Godot has already a lot of very good tools, and you should use them. So that's why you want to think about a separation of concerns. What is your specialization going to do versus what Godot is going to do? And even if you are going to take the initiative for a part, can you just change the interface for the Godot version of that? Because that's what you want actually to change, the workflow, not the actual technical thing behind. If it's good enough, it's good enough. So what I do in Castagne is that Castagne handles the core gameplay and Godot handles rendering, UI, and input. Physics, for instance, I said they need to be cross-platform deterministic over several CPUs. And that means that the float variables, the real numbers, they have limited precision. So they don't get computed the same over all CPUs. And that means you can get a desync. So that's why you want to keep that. So you need a new physics engine for it. And on the graphics, well, in this case, I only need to interface with the gameplay, to say, yeah, my dude is here, the other guy is here, Then how they get displayed and all that, that's not my problem. That's Godot's problem. And how they will be imported from Blender, thankfully, is Godot's problem. But the thing is that with such long and complex tools, making a game is almost mandatory, because first of all, that's what we're here for. But second of all, it's actually to ensure the quality and the suitability. That's a concept called dog fooding, actually, eating your own dog food. So the idea here is that show the project help reduce that risk. Because if you break something, well, it's easier to fix, and you can drive the tool a lot faster. That's why I tend to work on two projects at the same time. One is Planet Icons, that's the first one you've seen. It's an ambitious project, and this drives the need for the more advanced tools, because I can test all of that myself. And you got Molten Winds Open Edition, which is going to be open source and all that, which is the smaller one you've seen, like with Pixels. And this one is a short project, and it enables a very fast development. So that means I have to program the menus a lot faster, So that of course you need to do that. But so you have to direct your roadmap. You have to think about what you want to do, like the whole features, and you have to keep the roadmap in sync with the project. Because for instance, you have to balance a few factors. Like you have to balance your current needs. What is blocking me? What feature do I need? You have your future needs, but only those that will happen. Like I will need a menu. So you need to, that you have to implement that at some point. You got your technical constraints, which is like, yeah, well, I could do a hacky solution now, but I'm going to have a problem in a few months, and that's going to be annoying. And the logistics, that's something people don't think about too much, it's your team, their time, because not every team is going to have the same skill set, and not everybody is going to be available at the same time, especially if you're doing like dev on the side. So you have to think, yeah, well, who do I have in my team? And what's the skill level? That changes the architectural choices you make. And keep in mind, it's not static. You have to change it often. And for instance, in Castagne, I'm focusing on gameplay first. Like the idea is that you can make a gameplay. You can't run the game, but you can try it out. And that means you can iterate on it from the start, and you're not limited. The rest, exactly the particle effects or that can come after. You can already iterate on your gameplay. I want to spend extra time on being technically sound. If you're in a hurry, you make a hacky solution, and I continue my complex thing. But I want to be able to take care of high impact features, which would present themselves naturally during development, which can be a community need or a cool idea, that we want to implement as fast as possible to test it out. Because you always can't plan everything, even though I would like to, you must allow time for experimentation. And that's why I did that in several parts of the code. Because new paths will appear, new ways to do stuff. And you want to be able to take them. Remember, good code is code that is iterated upon, and tech debt is a resource. Don't tell that to your project manager. But tech debt is a resource, and you can take someone and you can repay it at key points. For instance, Castagne's script was not in the initial draft. That just evolved through organically, through a lot of discovery of what it can actually do and what you actually want it to do. And don't break production while you do that, because you're still working on the game, but don't break it too much. You can actually do a bit of that. The idea is that you want to be able to keep the door open to breaking the production, because you might find a better way to do stuff, and you're going to be stuck with that for a long time. But that's why small projects are good, because they're easier to fix. But tools exist to help you fix that, for instance, regular expressions or one-time Python script. Here's a small tip for that, by the way. If you're on your source control manager, I use a Git submodule for my specialization. So I have my whole Castagne folder, that's a submodule. And the idea is that each project I have, like I have a Godot development project, I have Cronian, I have Molten, each one has this same subrepo, and each one is on their own branch. So that means they can advance in parallel, and you can merge at your leisure. And that's a very efficient way, so that's a small bonus tip for you. So now we can get into who your users are. So you have to think about that a lot, actually. Because who is using your tool? What is their knowledge of game development and their skills in general? What do they want to achieve? And what are their main or daily tasks? This is important, because that's what you want to optimize. Yeah. If you heard Juan's talk earlier, you want to define your user. That's what that means. You don't make just a tool to create a game, because that's not that hard, actually. You want to create the tool that fits your team so they can make the game at a good quality. So TSN's target user is simple. It's me. Ooh, I know that guy. And other similar experts. But a secondary user type appeared over time. That's beginners, which have very low coding experience. And and that actually fits them pretty well, even though the choices are made for efficiency of experts. Having to write only 5 lines means you have only 5 lines to learn to make an attack. Then, because you're not alone, you have to think about how does your team interact, what jobs need to be done before others, but especially how you want your team to interact. You have to think about how your team will work together. And that's something we tend to skip over with just the technical stuff. For instance, Castagne, like one workflow can be programmers make the code and they expose parameters, very simply, and it's getting read by the engine to make an editor immediately. And that means this part can be handled by the programmer once, and the other one, well, the designer can spend the whole day changing the values while the programmer is probably fixing some bug somewhere instead of reading mails and sending bills to the designer. And that reduces iteration time a lot. And then, maybe once you have something that's pretty good, you could make it public, make it open source, make other people enjoy it. So that's, that's philosophical, that's a business strategy too, depending on who you ask, who you are. But you have some definitive advantages. I can get tests and contributions, for instance. But you have to think that not necessarily the same user demographic that you made the engine for is going to be using it's not going to be the same guy using that. For me, it's going to be beginners using it a lot. So was it good for Castagne? Well, it's getting there. That's what I would say. It allowed for some bug fixes and some features I didn't want to make myself, which is nice. But it's also a lot of extra work for communication. But it was very good for me, though. I really enjoyed it. So that's a win in my book. That's how you get it. You say it's a win, and then it's because you're the only one defining it, that's good. But yeah, something you need to keep in mind is to have clear communication if you're opening it up. You need to define the communication channels. So you want a clear roadmap, And I think you want to tell the why the roadmap is like this, so people understand your vision, and they can say if the engine is for them or not. Even if you change the roadmap and your vision, that's not a problem. Just tell them what happens. You want accessible info on a website, the docs, and signpost it correctly so people know where to get it. You want a gathering point for your community. GitHub is a possibility. Discord is another. Actually, mine is on Discord mostly because that's where fighting players live. And you can get feedback. So you can get some unobtrusive metrics. For instance, I know the number of downloads. But I also make a Castagne survey every year, in theory. But you can make it long. People usually want to help you when they get that. So they can take the 10-minute survey. They don't mind it. But try to use tools to make it smoother. Like I got a lot of Python script to help me get all of that. And something that will actually be very useful for open source, but even for closed source, is onboarding. Because as we know it, getting a new programmer on the team, that takes time. And what I think is important here is that first impressions are everything. So you want them to give them that initial momentum. So they get over the bump of learning a new thing, and they see the results, and then they have the energy to go all the way further. So for instance, I try to give several ways to learn. So you have the docs, which is text tutorials, which is very good for programmers and advanced users. But you also got video tutorials, which are better for artists, and procedures that are a bit complex and go outside of the engine. But what you want, what I really like, is in-engine tutorials, which is actually surprisingly easy to make with Godot, which is very good for beginners because they can make it directly. And it's really useful for you showcasing a feature, and it keeps it more to date because it works on the same code. And that's why when you open Castagne, you start with the in-engine tutorial, and that helps a lot of people over that initial barrier. But then you want to allow your best users to exist because you got your beginners now. But now you want to get your masters because your masters are the ones that are using the engine and pushing it out and to other people, but also pushing the limits and helping you on the code. So that's why you have to think, how do people learn? You guys, you make games. You know how to teach them. Just use the same tools here. So, beginners will use the basic tutorials, while an intermediate user in Castagne can explore the base Castagne script files. They are clearly documented. You can find out new stuff organically. Advanced user can create custom tools and modules. It's not that hard. It's somewhat explained. While experts can go into the code. And even then, the architecture is separated at key points. So that means if you want to change a bit of the physics engine, you don't have to be the guy that also knows how to do compilers, even though that will rely on it later.
Excuse me, you can use the mic again as well.
Cool. So I can use the mic to tell everybody bye. So, in conclusion, it's surprisingly practical, actually. It's a pretty practical way to supercharge workflow. I think I save more time, even with all of that to do. That can unlock many opportunities for you and for others if you are publishing out in open source. I've got a lot of people telling me, for instance, they're using it at the university to teach people how to make games. And that was very cool. And it's a strong way to shape your game dev experience. Because remind yourself, you're doing that every day. But you're in control of if it's going to be fun or not. So that's something to keep in mind, Have fun at work. That's why we do games. And here's a bonus for the people in the recording. This one doesn't work right now. I had to leave a bit too early from my city. But if you're looking at after the con, that should work and give you a page with a few links with that and the link of the slides. But yeah, so I thank you all for listening through thick and thin. And I'll now field questions if you have some.
I wanted to ask, first of all, thank you. And I wanted to ask, how does an in-engine tutorial look like, really? It sounds amazing. I'm a programmer, so I come from learning by doing, Yeah. And I would be really interested in how it would look like to do an in-engine tutorial.
So unfortunately, I don't have extra slides this time to showcase directly in screenshots. But the idea is that you start here, and you got like a text box, like in a VN. It tells you, welcome to Castagne, blah, 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 And then it can highlight. I got a small API I can use that's mostly, very simple and uses a lot of yield command. That way you make a long function and you yield like key points and you wait on the return to continue. And so it's like, here you go. Here's the button. This is the config menu. If you click here, And then when you get into and I got some API to also allow you to make code yourself. Like it says, okay, well, here's the code. Let's go. Welcome to the engine. Okay, you do an attack by doing this kinds of stuff. Okay, well, now try it yourself. You can play with the game and with the code at the same time. Give you a few tips. It's not super advanced yet, but it was made in one morning, so it was a very good investment for the time. And because Godot actually allows you to make fake button presses and to get info on a lot of what's on the UI, so that allows you to program it really fast. I mean, well, download the engine on castagnengine.com/download, and you can try it out for yourself with the first thing. If you want to see it in action.
Thank you.
Thank you for your talk. I'm going to try it out as well, but I would also be interested if you know of other frameworks that are like comparable but focusing on different kind of genres.
Okay, so here that's a good question. Which one? Oh, Medsys for Metroidvanias? Okay. So, yeah, well, at the moment I don't really know that much. I mean, I've kind of been focused on the PhD, you know, like in the lab. But it's soon over, so maybe I'll see more. But yeah, no, at the moment I don't really know a lot. I know maybe so if you want to do something more narrative, I think there are a lot of tools that can be almost like that, you know, like, no, I don't want to say something stupid, so I won't just use some of the things I haven't investigated yet, but I think they are for narrative purposes. Yeah. Yeah. Oh, by the way, using Godot allows you to mix and match several specialization. That's a small thing I didn't think about. Yeah? I don't know the person behind.
You talked about base Castagne scripts. Is
Yeah.
it tool written with your tool?
So the the idea is because I mean it's a Godot, you have to have some level of recursion. That's a joke. But what I mean is like Castagne by itself, it's only a state machine manager. That means the walking state is something that's done in Castagne script. So that means you can override the walking state. That means if you have a game that only has dashes, or a game that has no jumps, or a game that moves very weirdly, you can do that. You can rewrite how blocking works, you can rewrite all of that, but you have a base layer that just works, you know, that works out of the box and has some easy to use tools. So that's why it's a bit complex to say, because there's a lot of weird choices that are made, because the idea is that you have to balance between flexibility and usability. And I try to get both by doing something really complex for me. So, yeah, kind of Castagne standard library, yeah, exactly. That's a good way to put it. Yeah.
So how do you handle if, for example, you make a tool for a certain user, let's say a beginner,
Yeah.
and you think it's going to be amazing, but they don't understand it at all. But production it keeps going, and you need to, do I go back? Do I explain it better?
Yeah, so that depends a lot on your development philosophy. So for me, for instance, because I said it's for experts first, you know, I can say, well, you're not an expert, so that's not a really good way to do it. So the way I try to do that, I think, is that games have an inherent level of complexity. If you try to lower it below the actual level of complexity you have, then you get a lot of limits and you have a lot of complexities that still resurface, but people are not prepared to handle them. So instead, what I want to try is to explain it better, which is, I mean, easy to say, of course. That's why, you know, there's several learning paths. That's why I'm iterating on the tutorials. I'm working right now with a few persons. That's why I think metrics are very useful. Like, I don't have them right now because it's also easier to not be intrusive. But, you know, getting feedback from users, when there's a new guy coming in, I'm like, okay, well, did you enjoy the tutorials, all of that? You know, they tell me their feedback. I can adjust it a bit. I can have and if you have metrics, you can see, oh yeah, people tend to drop out at this part, or you can see, oh, they have trouble with these kinds of things, you know, and you can improve it over time. But a lot of people are going to want to get to it, and the in-engine tutorials give you that first push, and that means people are going to search. And that's very great, because that means people are not going to get stuck at the first obstacle. So that's how I see it. You know, are you... Yeah. Can you?
Question was when to decide what to extract the framework, because I have right now two
Yeah.
There are always these little differences that make it difficult to like factor and extract something in common.
Yeah.
And also sometimes I realize at one point in projects, yeah, but maybe I could, then there is this new feature that works only with this bus. And if I have to put the code in common, then it will make no sense on year one. Then I have to fill a lot of null or zero, or I have to like disable some code that the other project is
Okay.
doing with. So in this case, should I like just continue and see if it will work extracting something, or on the opposite, try to extract something very early to force me to think?
Okay, so I'm gonna rephrase the question so it's also recorded and a bit simplified. So you have a project, you have two projects that have a common part. I mean, some part that could be common, but they are completely separated right now. And you're wondering about the logic of how to extract and separate it. So especially you also say for an action game. So my advice is you take that code and you put Castagne instead. No, that's no. So the idea is that you have some code that's dependent on only one game. And the thing is that if you want to do a one size fits all, that actually doesn't work that much, because I mean it gets complex a lot. And you ask me, do I have to do that early? Well, that's useful, and that's my way of working. But that's because I tend to plan everything out early. But what you want to do in that case is that you have to remember about the modularity of something. Like in Castagne, for instance, every function of Castagne script is given by the modules. So if you want to do a 2D game, you use the 2D physics module, and it will give you the 2D physics move function. If you want to do a 3D game, you put the 3D physics module. And that means that, for instance, Cronian has its own module which handles the weird rendering stuff I explained last year. For instance, it handles some features that are hacky. Like I said, like if you are in a hurry, just make something happen. And that means but if you have code that's very specific to you, you can put that in a module and allow your engine to work with that. So of course that requires a bit of thinking, maybe some refactoring. That will take a bit of time, to extract something. And I can tell you that takes a lot of time because this is not sponsored by Ubisoft, but I work there. And we had Envil, which is used on a lot of projects, and that wasn't simple to do. And so even big studios take years to have that, So of course here you have more velocity, but that will still take some time. Yeah. But yeah, good luck with it. Yep. Oh yeah. You want me to re-explain it? Okay, so the idea, so it's a very small thing, but the idea is that when you want to use Git, for instance, to do that, the thing is that you have this part that is in common. So that's actually a very common use. He has 4 submodules. So a submodule is a Git repo inside of your Git repo. And so the idea is that in my Godot project, I usually use several repos for each project. For instance, Cronian has the main Cronian project, which has the code and all of that. And it has an asset repo because Git and files don't play very well. So I prefer keeping it separate. And I have my Castagne repo inside of it. And the Castagne repo, it's shared between several projects. That means it has the upstream branch. And with the submodules, the idea is that you can pull that branch whenever you want. So you can share code very easily and do that merge instead of doing copy-paste, which is going to be annoying whenever you have a change. And the idea is that you keep, because you have branches in Git, the idea is you can keep every project as its own branch inside of the main repo. So Cronian has the Castagne Cronian branch, Molten has the Castagne Molten branch, and I have a development project that's just to develop Castagne, which has its own branch. And that means I can pull the other ones at my leisure. I can still advance it, and I can advance, for instance, maybe Cronian wants to get a new update, but Molten doesn't. So I just merge the new branch on Cronian, and Molten can continue unimpeded. So that gives you control over when to break your production, which is, of course, extremely useful. And as a small tip additional, like the open source repo, like the one you see on GitHub, is another one. And I also have an internal branch for it, so I can merge with the common. But yeah, so that means you don't get all my weird commits like today. But yeah. Yeah. What? So everybody, I saw more hands at first. Like, you get shy. Yeah.
Is your this game written in Python? And you link it with Godot, or what's it written in?
So you're gonna have a stroke. It's in GDScript. So because I wanted to get iteration speed, and so that means like it's not a good choice for technical reasons because I mean I've got a compiler, but I can do as many compiler optimizations I want. I still run on GDScript. The idea, however, is that from the beginning it's made to be compiled. So right now I'm iterating and seeing all the problems I will find in the engine first. And that means you can still make a game solo. Don't try to put it online with rollback because it's not going to get enough performance. I mean, it works, but you're badly. But the thing is, like Castagne script, it has a lot of restrictions which don't seem apparent at first, but for instance, on inter-entity communications, which makes it able to be multi-threaded and work through a bytecode out of logic. So the idea is that when I get a first full version of the engine with all the bells and whistles I want to have, then I can rewrite it in a compiled language like C++ or Rust or whatever, you know, and keep the same user-side code, and that means your game just, in theory, works a lot faster. And that's something that's already validated because I already changed all the internals one time, and the Castagne scripts didn't break. You could use the same ones exactly. And then I broke it because I decided you have to do attacks differently, but that was me. That wasn't the internal problems. Well, I hope you enjoyed the talk. Don't hesitate to talk to me later. Of course, I'm here all day. Or to contact me, like I forgot to put my socials, but I'm Panthavma on Discord and Twitter. And, well, of course, don't hesitate to ping me now or later. And even to talk about cool line rendering stuff, which we can finally do in real time with that. But yeah, thank you for coming. And I hope you enjoyed the talk.